Hi guys, welcome to my channel, and this video is about reconciliation and why do we need reconciliation and what is reconciliation. So let's get started. So what is a reconciliation? Let's first discuss what is a reconciliation. So a reconciliation is a relation or an equation that describes a function in terms of smaller input. So let's first understand what is this. So as you know, we have written the recurrence relation of previously we have written the reconciliation of the Fibonacci series. So what was there? It was t of n is equals to t of n minus 1 plus t of n minus 2. So this is the reconciliation. So you can see we are writing, or we are defining a function in terms of its smaller input. Here it is n minus 1, here it is n minus 2. So what we are doing here, we are defining a function or describing a function in terms of its smaller input. So this is what reconciliation is. And why do we need reconciliation? Basically in this in our course, like this algorithms and data structure, we are using this recurrence, will be using this recurrence relation, and we will be solving this one. We will be solving this recurrence relation to find the time complexity. So if you are given with the equation like this, you are given the reconciliation of this Fibonacci series, how will you solve this? So there are three ways of solving a reconciliation. So there are three ways. One is like the substitution method. The second one is the recursive tree method. And third one is the master's theorem. And here comes like very important thing, like when you should go for substitution and when you should go for recursive tree method. So basically, according to the definition, like you will go with the substitution method when you have only one recursive term in your recurrence relation. So what does that mean? So let's say your recurrence relation looks like this. Let me change the color of my pen. So let's say your recurrence relation looks like this: t of n is equals to t of n minus 1 plus n. So you can see there is only one recursive term, t of n minus 1, and this is the non-recursive term. So when you have only one recursive term in your whole recurrence relation, you will go with the substitution method. In the contrary, if you have two terms, like before we have taken the example of the Fibonacci series, t of n into t of n minus 1 plus t of n minus 2. So when you have this kind of recurrence relation, you can see you have two. Just a minute. T of n is equals to t of n minus 1 plus t of n minus 2. So in this case, you can see there are two recursive terms in your whole recurrence relation. So in this case, you will go with the recursive tree method. So according to the previous video, we have discussed, like every recursive program, for every recursive program we can write a recurrence relation, and from recurrence relation we can find out the time complexity. So let's find out the time. Let's find out the let's go with the substitution method first. How we will solve recurrence relation using substitution method. So we will go with the example, first example, to solve the recurrence relation. So let's say we have a function like this: t of n is to t of n minus 1 plus n. So what is this? This is the recurrence relation. So what is the recurrence relation? For every recursive program, you can write a recurrence relation. So that relation is like here. This one, this one is this one. So you need to solve it to find the time complexity of that recursive program. So in the substitution method, what we do is like we substitute this. So we will find this one, and we'll substitute the value of this in this equation. So we will find t of n minus 1. So how will we find that? So we will see t of n minus 1. So we will take t of n minus 1. N minus 1 is equals to x. So we will take t of x. X is equals to n minus 1, we know. So t of x will be what? We have this formula, t of x will be t of x minus 1 plus x. So t of x minus 1. So let's write x minus 1 plus x. So what is this t of x? We can write t of x n minus 1 is equals to t of n minus 1 plus n minus 1. So we got t of n minus 2 plus n minus 1. So this is the value of t of n minus 1. So what we will do, we will substitute this value in this equation. So what we have got, t of n minus 1, sorry, t of n is equals to t of n minus 2 plus n minus 1. We have substituted this one here. Plus we had n, 1n. And again we need to find this one. So this one we got this after substituting t of n minus 1, we got this. So now we will find t of n minus 2. So let's find t of n minus 2. We can take n minus 2 as x. So t of x, we can write t of x minus 1 plus x. So t of x we know, n minus 2. T of n minus 2 minus 1 plus n minus 2. So we'll get t of n minus 3 plus n minus 2. So we will substitute the value of this in this. So let's see what we get after substituting. So this will be t of n is equals to t of n minus 3 plus n minus 2, and previously we had what, n minus 1 and plus n. So that, those things will be there, plus n minus 1 plus n. So we can see there is a pattern is forming, like you can see n minus 3, n minus 2, n minus 1, and we can write it n minus 0. So if we do this like k times, we have done is 3 times, like n minus 3 came, so n minus 3. So if we do this 3 like k times, what will be the output? So t of n will be there, it will be t of n minus k, and you can see here it is 3. So 3 minus 1 is there, so we can write it that t n minus k minus 1 plus n minus k minus 1 plus dot 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 n of minus 0. Sorry, n minus 1, this will be n minus 2, and this will go on like this, because you can see here we have 3. So if we take 3 as k here, you can see 3 k of k minus 1 is 2, k minus 2 is 1. So here we have done the same thing. So now and we know t of 1, and it will be given that t is equals to 1 for n is equals to 1. I forgot to write this thing, and for other n is greater than 1, we will have this equation. So recurrence relation is written like this. So we can see if we want to find t of 1 is equals to 1, so we have to find t of 1. So we want this to become 1. So n minus k is equals to 1. So we can write k is equals to, if we bring k this side, n minus 1 is equals to k. So now we will substitute the value of k here. So it will be t of n minus 1 plus n minus 1 minus 1 plus n minus 1 minus 2 plus dot 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 n minus 0. So here we can see what we get, n will cancel, and t of 1, this whole will cancel, we will get t of we will get just 2, we will get and then we cancel, we get 3 dot dot dot, and we'll get up to n. So this will be 1 plus 2 plus 3 plus 4 dot 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 n. You can see this is like this, this equation looks like the sum of the first n natural numbers. So what is the formula of to find the first n natural, the sum of the first n natural numbers will be n into n plus 1 divided by 2. If I am not wrong, this is the formula. Just let me check once. Yeah, n into n minus 1 plus 2. So what will, so you can see we can write, this is the time complexity, this is the exact tn, this is the exact tn. So time complexity will be tn of big O of n square. You can see there's 2 n terms, so it will be big O of n square. So this will be the worst time complexity. This is how you find how we solve our reconciliation using substitution method to find the time complexity. So let's take another example, and so we have taken a second example here, which is t of n is equals to 1 if n is equals to 1, and t of n minus 1 into n if n is greater than 1. So as you studied, what is like reconciliation is writing a function in terms of its smaller input. So it is n minus 1 into n. and this one is a non-recursive term, you can see. So n is a non-recursive term, and just a minute. Yeah, so what we have got, t of n is equals to t of n minus 1 into n. Let me add one page. Yeah, so as we have seen in the last one, what we need to do, we need to find this one. We need to find this one and substitute that the value of this in this function only. So let's find t of n minus 1. We can think of t of n minus 1 as x. I mean this n minus 1 as x. So what, t of x. So we have this function to find t of x. What we need to do to find t of x, we need to put t of x minus 1 into x. Here x is n minus 1, so we can put n minus 1 into n minus 1. So this is t of n minus 2 into n minus 1. This is the value we have got for t of n minus 1. So we'll just substitute this value here. So let's say what we get, t of n is equals to t of n minus 2 into t of n minus 1, and we have the n left into n. So now we have got this function after substituting the value of t n minus 1. So now we will find t n minus 2. So let's see what we get for t n minus 2. So again we will find t of n minus 2. So let's take n minus 2 is equals to x. So t of x is equals to t of x minus 1 into x. So what we get, t of n minus 2, x is n minus 2, so we'll put t of n minus 2 minus 1 into n minus 2. So we get t of n minus 3 into n minus 2. So now what we got, t of n minus 2. So this we will substitute inside this. So let's see what we get. We will get t of n is equals to t of n minus 3 into n minus 2 into n, and we have these two terms left, n minus 1 and n minus n minus 1 and n. So we will put it here into n minus 1 into n. So this is what we got after substituting the value 3 times. So we can like if we do it like k times, what we will get, we have done it 3 times, we got this. So if we do this k times, we will get t of n. So now if we do this k times, what will happen? So if we do this k times, we will get t of n minus k into n minus k minus 1 into n minus k minus 2 into dot 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 n. So how did we came here? So let's put like let's take k is equals to 3. So n minus the k is equals to 3 will be 3. 3 minus 1, 2. 3 minus, if we put k is equals to here, 3. So k is equals to 3. K minus 1 is 2. K minus 2 is equals to 1. So this satisfies. So what we can do is like, yeah. So as per the equation, what we have got like this. So if t of 1 is 1, so we want this to be 1. If this is 1, we will get 1. If n is equals to 1, we will get, if n is equals to 1, we will get t of 1 is equals to 1. So like, yeah, so we want to make this one. So n minus k is equals to 1. So k will be n minus 1. So if I put this value of k here, so we will get t of n minus 1 into n minus 1 minus 1 into n minus 1 minus 2 into dot 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 n. So what are we getting here? N will cancel and we got t of 1 into, this will get 2, this will get 3, we will get up to n. So what we are getting is n, just a minute. Yeah, so it is like factorial of n, you can tell. So it is n factorial. So the tn is n factorial. So we want to get the big O. So what will the big O? Big O will be O of n to the power n. So this is exactly t of n, and we want n to the power n. So we want an upper bound of this function. So the upper bound will be n to the power n. So this is big O of n to the power n. You can take any function that is bigger than this n factorial. So the function bigger than n factorial is n to the power n. So we are taking this as big O f. So what is big O? Like we know that a function is this one and a function is this one. This is f of n and this is g of n. So what in big O, what do we say? F of n belongs to big O of g of n. Big O of g of n only if f of n is less than some constant into g of n, such that n value is greater than n0. So what f of n is here? N factorial. So what we want? We want a function which is greater than that, so that it can be the upper bound. So what we took? N to the power n. So this will be the upper bound of n factorial. So this is what substitution method is, and with this we find the time complexity of a time complexity of a recursive program by its recurrence relation. Thanks for watching this video.